Now that we've reviewed complex numbers in the last section, let's go and look to see how complex numbers relates to trigonometry in the polar coordinate system, or at least polar form of complex numbers. So to get started, let's go ahead and do a quick little review. Remember, a plus bi was the standard form of a complex number. We also call this rectangular form. And it's going to be important that we kind of recognize this different forms, because we're going to have rectangular form, we're going to have polar form, we're going to have trigonometric form. So again, we have to make sure that we understand the differences here. So this is the standard form or the rectangular form of a complex number. We're going to be graphing these, and as soon as we start graphing these, what ends up happening is I'm going to graph this value on the horizontal axis, this value of b on the vertical axis, and so another way I can write this is x plus yi for graphing. And then given this information, I can start looking at a couple different things. I could look at r cosine of theta plus I sine theta is taking this x plus yi, or the a plus bi, and rewriting it, and this would be the trigonometric or the polar form. Of a plus bi or x plus yi, however you want to think about that. Now, a way we can shortcut this, and I don't write it like this, but you'll see it in your homework like this, so I want you to be familiar with this. They take this part inside cosine theta plus I sine theta, and they call it cis theta. So they call this r cis theta, where cis theta is equal to the cosine of theta plus I sine of theta. So whenever I see it written as cis theta, I go ahead and rewrite it as cosine theta plus I sine theta. It makes it a little bit easier to work with. I don't like that shorthand notation. Now, a couple of things that we want to recall from previous units. Remember that cosine of theta, when we were working with the unit circle and we were talking about the unit circle approach to defining trigonometry, cosine of theta was equal to x over r. Well, if we solve this for x, we get x is equal to r cosine of theta. Sine of theta was y over r. If we solve for y, I get y equal r sine of theta. If you'll recall, we also had a tangent theta. Tangent was sine over cosine, or y over x, where x cannot equal 0. And then we also had x squared plus y squared equals r squared. And if we solve this for r, I get r equals the square root of x squared plus y squared. Now please note, I can't take that square root sign and distribute it across the sum. You can never do this. So when we're talking about the different forms, we need to talk about how we convert from one form to the other. So let's go ahead and look at trig or polar form to rectangular form. This is the easier of the two conversions. So what we have in trig or polar form is r cosine theta plus I sine theta. Now whenever it's in trig or polar form, keep in mind that the arguments, the thetas, have to be the same for both. So meaning this has to be 45 degrees and 45 degrees. It can't be 30 degrees and 180 degrees or something. Those arguments have to be the same value. So basically what I do is I find the cosine and I find the sine of whatever angle is given, and I distribute the r and simplify. So distribute and simplify until we get it into a form to x plus yi. So that's the easier of the two. Now when we convert from rectangular to either trig slash polar form, it's going to be a little bit more involved. So the first thing I will do is I'll sketch x plus yi, and we'll practice sketching these in a bit. And note the quadrant that you are in. It's going to be important to remember the quadrant, because that'll affect what my angle will be in the end for theta. The second step that we're going to do here is to go ahead and find r. And remember, r equals the square root of x squared plus y squared. And the third step is to find theta using the fact that the tangent of theta equals y over x. X cannot equal 0, and quadrant from number 1. Okay, so those are my quick notes on what I'm going to be doing here. And then we're just going to go ahead and run through a lot of different types of problems next. One thing you'll want to make sure is you know your unit circle as usual. If you don't know it yet, you might want to pull out a unit circle that you filled out previously and use that as a reference. So a lot of these are going to be asking us to graph. So let's go ahead and look at how we graph a complex number. Now remember, if we're thinking about complex numbers, I could rewrite this -3 plus 8i as x plus yi. So this could be the same as x plus yi. In this case, x would equal -3 and y would equal 8. So if we look at these values, we're used to thinking about the x-axis and the y-axis, but really we need to think about the real and then the complex planes. So I take the value of x, or the real component, and I move 3 in the negative direction, and then I move up 8. And that would be this value right here. And then of course that's from the origin. So that would be the vector that I've drawn from the origin into the third quadrant. So again, I can think of this as a plus bi, and the real plus complex I, if you want to think about it like that. But the real is the horizontal, and the vertical is the complex component. So let's go ahead and look at practicing a couple more graphs, and then we'll also look at converting. Now converting is going to be an important skill to have, because sometimes one form is a little bit easier to work with than another. So this one will be graphing the number as a vector in the complex plane. The complex plane basically means taking the Cartesian coordinate system and thinking about it as real and complex versus x and y. So here's my real component. Here's my complex component. And if I want to think of real as x and complex as y, that works as well. So this is a plus bi form, which is x plus yi when I start thinking of the horizontal and the vertical. So 3i would be 0 plus 3i. So x would equal 0, y would equal 3. So the point 0, 3 would be right here on the vertical axis. So starting at the origin, going through would be this red line right here. So this would be the value that I would be looking for, or the vector that I'd be looking for when I graph 3i. Next, let's go ahead and look at converting. Now again, knowledge of the unit circle is going to be very important here. If you don't know your unit circle, these will be very difficult. So the first thing that we're going to do says for the complex number shown to the right, give its rectangular form and its trigonometric form. So they're giving us a graph that we need to look at and paste in, because that graph gives us the information that we need to have in order to work this problem. Okay, so this is that value right here. This is a little bit hard to see what's going on here for sure, so let's blow it up a little bit. But if we look at the x value here, and bring it straight down, it looks like to me that it's crossing at 13, and it's crossing up here at 13. So if I were to write this out, the real component would be 13. The complex component would also be 13. So a plus bi, x plus yi would be 13 plus 13i. So that's its rectangular form. Now what I want to do is I want to take it from its rectangular form and find its trigonometric form. So to find the trigonometric or the polar form, let's go ahead and run through those steps. Now our first step was to graph. That's already done with this. So our first step is to graph, and we need to note that it's in quadrant 1. That's going to be important. The next thing that we're going to do is we are going to find theta. And we can come right up here and see those steps, or sorry, find r, and then we'll find theta. So let's go ahead and find r first, and then find theta. So find r. r is equal to the square root of x squared plus y squared. X is equal to 13, y is equal to 13. So r is the square root of 13 squared plus 13 squared, 169 plus 169. Okay, and we'll keep looking here. So 169 plus 169 is going to be 338 square rooted. And then what I want to do is I want to figure out if there's any factors of 338 that are perfect squares. Now, of course, we already know the answer to this because we already know that 2 times 169 is 338. So I could rewrite this as root 169 root 2. So r would equal 13 root 2. Now, next thing we can do is find theta. And we're going to find theta by looking at the ratio for the tangent of theta is y over x. So we get the tangent of theta is y, which was 13 over x, which is 13. 13 divided by 13 is 1. So I have the tangent of theta is 1. Well, in quadrant 1, that would mean 45 degrees or pi over 4, depending on if you're working in degrees or radians. So you have to look at the problem in my math lab and see what they suggest your solution be, and they'll usually give you 0 to 360 or 0 to 2 pi, and it looks like in our problem they gave us 0 to 360. So we want to work with the pi over 4. Now, tangent is also equal to a positive 1 in the third quadrant. So that would be at 5 pi over 4. But usually we want to pick the least positive value. So I said 5 pi over 4, that's in radians. So in degrees, that would be 180 plus 45 degrees would be 225. But again, we want to use the least positive value. So now when I rewrite this, I have r cosine theta plus I sine theta. r is equal to 13 root 2 cosine of 45 degrees plus I sine of 45 degrees. And so that would be our trigonometric or polar form. And again, for this angle in degrees, I could have chosen one from the third quadrant, but we usually want to pick the least positive angle to put in there. And again, always double check whether you're working in degrees or radians. So for this one, it says find the sum of the pair of complex numbers, then graph both complex and their resultant. So if we think about this, 6 minus 6i, find the sum, so we'll be adding negative 2 plus 3i. Just like we did previously, I'll take the real components and combine them, 6 minus 2, and then the complex components, negative 6i plus 3i. 6 minus 2 is 4, negative 6i plus 3i is minus 3i. So 4 minus 3i is the resultant value. Now it asks us to graph this as well. So as we look at this and graph it, 6 minus 6i I'm going to do in blue, or sorry, green, that's green. So that would be 6, negative 6. So that would be this vector. Whoops, missed that by a long shot. So again, this is 6 minus 6i. Next one I'll do in purple, negative 2 plus 3i. So negative 2 plus 3i would be this vector. And then the resultant vector would be 4 minus 3i. So 1, 2, 3, 4, down 3. It's almost right on top of this one. My scale probably throws it off a little bit, but that's the resultant vector, is the 4 minus 3i. And again, it's almost right on top. The angle is going to be a little bit different if we had an exact, but you can see kind of what we're getting at there. So when we're combining these, when I sum two of these complex numbers and I get another complex number, that would be like adding two vectors together. Let's go ahead and look at some other examples where we're converting in the other direction. This one we'll be looking at taking a complex number in polar or trigonometric form and rewriting it in rectangular form. So again, knowing your unit circle is going to be very important here. So the easy way to convert here is to figure out what the cosine of 225 is and the sine of 225 and kind of work from there. Well, 225 is in quadrant 3, and the reference angle for 225 is 45 degrees, because 180 plus 45 is that 225 degrees. So I'm in quadrant 3, where both sine and cosine are negative. So the reference angle is 45, so that means both sine and cosine are a negative square root of 2 over 2. So I will take 10, and the cosine of 225 is negative square root of 2 over 2, plus I times the sine of 225 is negative square root of 2 over 2 as well. So simplifying, I get a negative 10 root 2 over 2 minus 10I root 2 over 2. And of course canceling can occur here. 2 goes into 2 once, 2 goes into negative 10 negative 5 times, don't drop that negative, and the same over here. So I get negative 5 square roots of 2 minus 5I square roots of 2. And this would be my rectangular form. And this that we started with was polar or trig form, trigonometric form. So that's to me the easier conversion, because we don't have to really figure out what quadrant we're in. We don't have to do anything else in terms of writing the vector first. We just have to evaluate that expression, combine like terms, and kind of work from there. Let's look at one with that shorthand notation as well, so I can show you how to convert that. And again, I don't favor this shorthand notation because I don't want there to be any points of confusion. So I always try and rewrite this right away first of all. Okay, so it says write the complex number in rectangular form. Well, let's recall rectangular form is going to be the x plus yi or a plus bi. Either one of these are the same thing really. So let's write out what this means. This is polar or trigonometric form. So this is going to be 5. The c stands for cosine of 150 plus I sine of 150. That's what that cis 150 means. So I'm going to go ahead and figure out where the cosine of 150 is. 150 would be in quadrant 2. The reference angle here would be 30 degrees to get me to that 180. So my cosine will be negative, my sine will be positive because I'm in quadrant 2. So the cosine of 150 degrees is going to be a negative square root of 3 over 2 plus I. The sine of 150 degrees would be the same as the sine of 30 degrees, which is going to be 1/2. So this is negative 5 square roots of 3 over 2 plus 1/2 I. So this is my a plus bi form. It's not nice integers like we usually have, but it's definitely, whoops, bring that back down here, but it's definitely going to be that a plus bi or x plus yi form. This is 5. I have to distribute here as well, so 5/2 I. So this is my rectangular form. And again, as long as you know your values from your circle, it's not a huge deal. You just need to make sure you have the correct values for sine and cosine. The next problem that we're going to look at, you might look at it and think, well, wait a minute, this doesn't have all the correct components I need. They're all there, but we're going to have to be a little bit imaginative when it comes to writing this out. So this says write the complex number in trigonometric form with theta in the interval of 0 to 360. So again, if we think about x plus yi, this would be 0 plus 6i. So x is equal to 0, y is equal to 6. So to get started, our first step, okay, so we want to rewrite this or convert this. The first step in converting is to graph. and figure out which quadrant we're in. Well, in this particular case, I'm not in a quadrant. So 0 and then 6. I'm on this point right here on the y-axis, so I'm not in a quadrant. So that's something to remember. So I'm going to graph this, and I'm on a quadrantial angle. I'm at 90 degrees. So next we're going to solve for r. R is the square root of x squared plus y squared. X squared is 0 squared plus 6 squared. 6 squared is 36. The square root of 36 is 6. So that's 6 for r. Third step, I'm going to find theta, and I'll do tangent theta is equal to y over x. Y in this case was 6 over 0, but this is undefined. Well, that provides me information as well. Where is tangent undefined? Tangent of 90 degrees is going to be undefined. Sine over cosine. Cosine is 0, so this is undefined. So 90 degrees is my angle. Now it could also be 270, I guess, if we wanted to think about where tangent is undefined, but remember we're up here between quadrants 1 and 2, so I need to use that 90 degree angle. So again, I'm going to put this into r cosine theta plus I sine theta. R is equal to 6 cosine of 90 degrees plus I sine of 90 degrees. And this would be my trig or my polar form. So sometimes those can look a little bit different when they're missing, either the x or the y, but the big important thing to remember here is just to write it out anyway and go through the steps of solving it, and you should be able to pretty quickly see what's going on there. Let's do another one similar to that, but instead of this one having the complex form, this one, instead of missing the real form, this one's missing the complex form. Okay, so we have -8 here. And again, we want to look at x plus yi. So this is going to be -8 plus 0i. So x is equal to a -8, y is equal to 0. So here's where x is equal to a -8. So this is a vector that lies along the x-axis, and in particular the negative x direction. So the first thing I'm going to do is I'm going to graph this, which we just did. And I'm going to note which quadrant I'm in. I'm between two quadrants here. Since I'm at a quadrantial angle, I'm in between quadrants 2 and 3. So this would be 180 degrees, or pi if we were working in radians. This one we're in degrees up here. Next, I'm going to solve for r. R is the square root of x squared plus y squared. So x is -8 quantity squared plus 0 squared. Square root of 64. R is equal to 8. Now I want to note something important here. If I would have put in -8 squared like this, that would have been a -64. If the -8 is in parentheses as it should be, I will get a +64. So you always need to put the parentheses around the base of whatever the exponent is. Okay, next step, we are going to figure out what theta is. Tangent of theta is y over x. Y in this case is 0 over -8, so I have tangent theta is equal to 0. So theta, and again we want the least positive angle here. We have to keep in mind that for the tangent of theta equaling to 0, that's where the sine is 0 and the cosine is any other number other than 0. So this would be at 0 degrees. Now we know this would be at 0 degrees because the sine is 0 and the cosine is 1. Now this could also happen at 180 degrees, and that has to be the case for this one because of this value of -8. So 0 degrees would work, but that's kind of pointing us in the wrong direction. So we need to look for the least positive one that lies on this line, and that would mean I would need to use 180 degrees here. So I'm going to use r, which is 8 cosine of 180 degrees plus I sine of 180 degrees. Okay, and this is my trig or my polar form. And what I was given up here to start with was rectangular. It doesn't look rectangular because it's just the number 8, but it is rectangular. And if I were to find cosine and sine and distribute the 8, I would get 8 right back. So these convert forward as well as backward. Now your calculator converts these polar and trigonometric forms as well in rectangular form. It's under the angle function, the second angle function, and you can look at that as well. But once again, you have to keep in mind that what we're looking at here is not just an answer but actually showing your work. Okay, let's do one last problem. This is probably one of the shorter lectures that you've ever had in this class, but hopefully I've gone through plenty of examples for you. This one says write the complex number in trigonometric form. So this is rectangular form. And so this would mean x is -3, y is 5. So the first thing that we do is we graph this and we figure out which quadrant we're in. So -3, 5. Okay, so -3 up 5. So it's the vector that goes right through there. So this is in quadrant 2. Okay, cosine's negative, sine is positive. Second step, we're going to find r. R is the square root of x squared plus y squared. So this is -3, and remember this has to be in parentheses, squared plus 5 squared. 9 plus 25, square root of 34. Now that's my value for r. The next thing I'm going to do, and 34 is 17 times 2. That doesn't break down with any factors that are perfect squares, so I'm good to go. Next thing I'm going to do is to find theta. And I'll find theta by looking at the tangent of theta is y over x. Now y in this case is 5, x is -3. This does not look familiar to me at all. So this is not a value from the unit circle, a standard angle, let's say like 1, 0, square root of 3, square root of 3 over 3. None of these are common. So what I'm going to have to do here is I'm going to have to look at inverse trig functions and use our calculator. So I have tangent theta equals -5/3. So what I can do here is take the inverse tangent of both sides, and I get inverse tangent of -5/3 is equal to theta. So let's go ahead and grab the calculator. And the first thing I want to do is to make sure we're in degree mode, because we're supposed to be working in degrees, and I know this because up here it shows us degrees. Okay, so I have the inverse tangent of -5/3. Okay, and this is -59.04 degrees. Now this is a bit of a problem because this is putting me in quadrant 4. -59.04 degrees is in quadrant 4. Well, remember the restrictions for your trig functions. Inverse tangent was restricted from negative to positive pi over 2, so fourth to first quadrant. So let's think about what we're going to have to do here. I'm supposed to find 0 to 360. Tangent is negative right up here in quadrant 2. So we're going to have to use this information to help me flip up into quadrant 2 and find the appropriate angle. So let's just call this -59 to make this a little bit easier. So -59 degrees is somewhere right here. So our reference angle is positive 59 degrees because it's the distance from the terminal side of the angle to the nearest horizontal axis. So I'm going to come over here and I'm going to go up 59 degrees. So this is 59 degrees. And then the resultant angle that I want to find is this angle that I'm going to use for theta. Okay, so let's think about this. This is 180 degrees minus 59, which leaves me with 121 degrees. So now I know r, what was r? Square root of 34 plus cosine of theta, which we figured out was 121 degrees, plus I sine of 121 degrees. And this is the polar or the trigonometric form, given we started with that rectangular form. So as usual, make sure you sketch everything out. Make sure you know your unit circle. If you get stuck while you're working on these, please take a screenshot and you can text it to me with your work or with the original problem so I can help you out. Good luck.